try a new toy out. So I figured out a minute ago how to Laplace transform unit step functions times functions. And here I have, surprisingly enough, a unit step function times a function. So let's Laplace transform that thing and see how the formula works. So looking at that, what's tau? Positive 2. So that tells you tau is 2, right? 2 is the time at which interesting stuff starts to happen for this function, right? So I just go look at the table, and it says I should have an e to the minus s times 2. So let's write that like people, e to the minus 2s. And then we should have the Laplace transform of f of t plus 2.
So quantity t plus minus 2 minus 2 squared?
Okay. I would encourage careful writing at this stage. So this thing here is f of t is t squared minus 4, right? Like that's my function.
Okay.
And then you need to shove a t plus 2 in there, right? So this is going to be the Laplace transform of the quantity t plus 2 squared minus 4 in this case. I advise for you not to look in the table for that. What should you do? This thing. Jazz fingers at it until it decides to give up. Yeah, so multiply that chunk out. So you got an e to the minus 2s, and then you've got the Laplace transform of, let's see, that's this whole business is t squared plus 4t plus 4, right?
Minus 4.
And then minus 4. Cool, so I need to Laplace transform t squared plus 4t, right?
Yeah.
So I may as well exploit linearity for myself here. Right? Make sure you get your e to the minus 2s times everything. Okay? Table? I guess I should have arrows here instead of equality since, okay. That was table. That's what? Algebra and linearity. Then table. So you get a e to the minus 2s. What's the Laplace transform of t squared?
2 over s to the third.
2 factorial over s to the 2 plus 1. Pretty sure. And then I need a plus 4 times Laplace transform of t is
1 over t squared.
1 factorial over
s squared. Yeah, that would be 1 factorial over s to the 1 plus 1. Okay? So I think I got e to the minus 2e to the minus 2s over s cubed plus 4e to the minus 2s over s squared. I don't know why I left my exponentials on top with negative powers, but I did. What else? Cool. Question sealed. What's this good for?
Yeah.
You have a spring and a switch for gravity.
Alright.
Does that mean
Just
if
have
we...
a switch, you know?
Yeah, or if you just have a switch to turn on an electromagnetic field and a spring in it. Right?
Okay, yeah. We can keep.
Well, you need some reason to have the differential equation to start with, right? So I guess you could do
Yeah.
mass times
all the way
acceleration in a field, right?
Or a conductor with a capacitor.
Yeah.
Perfect, yeah, or electronics. I don't know anything about electronics.
So if we're inverse Laplacian and we have a factor of e to the same number everywhere, we're gonna
Yep.
heavy sided.
So if you see an e to the minus something s, you might think to yourself, aha, that came from a unit step function. So then I should look around for the Laplace transform of some function I recognize shifted around. And that gets a little bit challenging. Let's call that. Like to inverse Laplace transform this, right?
Yeah.
You'd be like, huh? Because to notice, right? You're going to notice that e to the minus 2s's, right? Those all go to the same spot, right? Those are the same unit step function. So that'd clue you into doing something like this. But to step back from here, well, I guess that's okay, right? Step back to these guys. And then you kind of need to find that shift, which is a little funky.
Yeah, then back
See
to
that?
tau.
That's a little weird sometimes. Yeah. These get a little bit tough. Don't lie. It's usually this last step where you're like, wait. What was that? Shifted, what? Dang it.
The plus
So,
was minus
I imagine there's going to be problems where it's like you have this unit step function and then you have your e to the tau s or whatever. Is that going to be, we're going to multiply those sometimes by inverse Laplaces that are also e's? Like, are the Laplaces at e?
Oh,
If
with
you were trying to
the,
inverse?
so the good news is that the e to the minus 2s thing, right? That always is going to say unit step function. You
Okay.
flip through your table, right?
Well, I did yesterday, but I don't have it with me right now.
So if you look through that thing, there's not something else that gives you an e to the minus 2 whatever, or e to
Oh,
the minus
isn't?
as.
Okay.
Yeah, those always come from
I was
unit
just
step
wondering because
function.
then it'd be really tough to tell because you'd be having like exponent rules with your e's. that
Yeah, you'd have like
added in
some
there.
e's that came from unit step functions
Yeah,
and some e's
that's what I
that
was
came
wondering
from.
if we ever got in a situation like
No, no. So you guys, if you see e to the minus constant times an s, and you
Assumes
need,
this.
and you're already in Magic Land, right? You better be in Magic Land because you got s's. So if you need to back out of that, you're thinking, okay, that's a unit step function, and it's a challenge to get back out of that rabbit hole, but you can do it.
Okay, I just wanted to make sure, yeah, we weren't going to be.
Yeah, no, you're not going to have them
Values of
kicking
E.
around from someplace else. Cool with it?
Just going backward, you get t squared plus 4 t, and then be like, okay, how do I tau?
Yeah, so if you were going backwards, right, you'd get to this point where you have t squared plus 4t.
You'd have to complete the square.
And then you'd be like, okay, so I had f of t plus 2, right? And out of that, I got t squared plus 4t. Okay, well, what the heck did I evaluate at t plus 2? Like, oh, I kind of see a t plus 2. It's part of that. So I complete this square and be like, haha, there's a t plus 2. Sucker, I found you. Right? But that takes a little creativity and they get hard. So if you get to that point, I'm totally okay with you guys saying, I tried, man. Like, I tried. Cool? These ones especially don't come particularly well on tests. Like, we've definitely seen that in the past, that it's like, I don't know, something, panic, algebra, panic algebra.